Alright guys, today we're going to look at a shortcut for finding derivatives. So instead of using that entire limit definition, sometimes we can find derivatives a simpler way. And this is something called the power rule. So the power rule is actually pretty easy to use. What we do, this works really well when you have a function that's x raised to some exponent. So if I have x to the n power, and n is some number, then the way I would find the derivative is I would take that exponent and move it to the front, and multiply it, which is what I have over there, and then I subtract 1 from the exponent. Okay, so that's the actual rule. So the application of it, again, it's pretty simple when you see an example. If I have the function 4x squared, I take the exponent, I multiply it by the number in front, and then I subtract 1 from the exponent. And then I don't need to write that 1 exponent. We know x to the 1 power is just 1. So that means the derivative of the function 4x squared is 8x. Alright, now if I have multiple terms, just like I could with limits, I can find those derivatives as well for just each individual term. So I'm going to start with the first one. I'm going to use the power rule to find the derivative of 3x to the third power. So I'm going to move the exponent to the front and multiply by the 3, so 3 times 3 gives me 9x. I subtract 1 from the exponent. Then I go to my next term. I move the 2 to the front and multiply, take 1 from the exponent, and then I do the same thing here. Now remember, that's x to the 1 power, so I multiply by the 1, and when I subtract, 1 minus 1 is 0. So I'm left with 0 x's, which means my derivative there is just 7. Alright, now one more that I want to look at is if I have, let's say I have the function f of x equals just 7, or any constant number. Okay, in order to find the derivative of that function, it's going to be really easy. It's going to have the same rule every single time. If you think about if I have just some straight line, the slope of the tangent line at every single point in that line is going to be, it's a horizontal line, which means at every point on there, the slope of the tangent line is 0. And it doesn't matter where that horizontal line is. Anywhere I have a horizontal line, I'm going to have the same horizontal tangent slope, which is 0. So any constant function is going to have a derivative of 0. Alright, now the next two examples we actually can continue to use the power rule. We're just going to need to rewrite these functions first to see it. So we know from our exponent rules that 2 times the square root of x, that's the same thing as 2 times x to the 1/2 power. And now I can continue to use the power rule. So I move the exponent and multiply. 2 times 1/2 is just 1. And then I subtract 1 from my exponent. So that means my derivative is going to be x to the negative 1/2 power. And again, I can rewrite that. That's the same thing as 1 over the square root of x. And that's my derivative. Same idea on this function. If I rewrite this using exponent rules, I know this is the same thing as 3 times x to the negative 2 power. So using those exponent rules, I can easily use the power rule. So again, following the power rule, I multiply, subtract 1 from the exponent, and then I can rewrite this as negative 6 over x cubed. And I found my derivative. Alright, so the last thing that the power rule can help me find is it can also help me when I have actually a limit definition written down. If you guys can recognize that this function is a derivative. So we know the limit definition of derivative is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So if I see something that looks like this with a certain function, I can figure out what that derivative is. So if you look at this first limit, everything on here matches except my f of x in that case is the function 2x to the 4th. So if my function on that limit there is 2x to the 4th, and that's the definition of a derivative, then I can just use the power rule to find my derivative. So my derivative would be 8x cubed. And I would get the same thing if I multiply that whole thing out and worked out that whole definition. Now same thing on this one, but this one it has one extra step. We have to realize here, if I replace that 2 with an x, then you guys can see your function. My function is x to the 4th power. So what I have to realize here is I need to find my derivative, but I'm not just finding f prime of x. I'm actually finding f prime of 2. Because that's what happened. I had that function x to the 4th, but I replaced the x with a 2. So let's go ahead and find the derivative using the power rule. It's going to give me 4x cubed. Then I can find f prime of 2, which is what that top limit is, by plugging in 2 to that derivative. So I have 4 times 2 to the 3rd power, which is 4 times 8, which is 32. Alright, so anytime you guys can recognize that you're using a limit definition to find derivative, if you see that's just a function that can be used with the power rule, you can go ahead and use that shortcut.